इस क्वेश्चन में एक पुली गिवन है ऑफ रेडियस 1.5 मीटर rotated about its axis by a force 12t minus 3t square. Point to be noted here is the force depends on the time, hence it is of varying nature. This force is applied tangentially, as you can in the C diagram. If the moment of inertia of the pulley about axis of rotation is 4.5 kg meter square, the number of rotations made by the pulley before its direction of motion is reversed will be k by pi. This is basically pi. The value of k is asked. So what is given? Given is force, which is a function of time, 12t minus 3t square. Radius is given as 1.5 meter and moment of inertia is given as 4.5 kg meter square. Using the force and the radius, we can calculate the torque function, which is the simple multiplication of radius and f, and it can be written as 18t minus 1.5 into 3, that is 4.5 t square. Okay, inertia is given as, moment of inertia is given as 4.5 kg meter square, hence we can write alpha equal to torque upon moment of inertia. Dividing the torque equation with the moment of inertia, we can write 4t minus t square. Alright, so this is the expression of alpha, that is the angular acceleration of the pulley. Alpha can be written as d omega by dt. Actually, we need to find the number of rotations made by the pulley before its direction of motion is reversed. So first of all, we need to find out at what time instant the direction of pulley will get reversed. We need to find that time instant. So from the projectile motion, this is very common understanding, which you already know. When the direction is reversed, at that point of time the velocity is 0. Similarly here, when the direction of the pulley is being reversed, the omega will be 0 at that time instant. So for that, we first need to find out the omega equation. We will find the roots of that equation. From there we will get the time value. So that's why we are breaking the angular acceleration alpha into d omega by dt, which can be written as 4t minus t square. Now rearranging this equation, we get d omega equal to 4t dt minus t square dt. Integrating from 0 to t and from 0 to omega, we get the equation as omega limits 0 to omega 4 t square by 2 limits 0 to t minus t cube by 3 limits 0 to t. Hence we can write omega equation as omega equal to 4t square by 2, which can be written as 2t square minus t cube by 3. Taking t square common, we get 2 minus t by 3. Putting omega equal to 0, to find the roots, we get t is equal to 0, comma t is equal to 6 seconds. Means these are the two time instants at which the angular velocity omega will be 0. So t is equal to 6 is the instant at which the direction of the pulley is being reversed. So in order to calculate the theta, that is the angular displacement covered from t is equal to 0 to t equal to 6 seconds. Here we cannot use that equation. If this equation is coming into your mind, then this is not applicable. The reason is, this equation is valid for uniformly accelerated rotational motion. This is not a case of uniformly accelerated rotational motion, because the force applied is variable in nature, hence the angular acceleration is variable in nature. What we need to do here is, we need to use the omega equation, which is nothing but 2t square minus t cube by 3, and find out the expression of theta. As we know, omega can be written as d theta by dt, hence From here we will rearrange this equation so that we can integrate with the proper limits. So let's set the proper limits 0 to theta, time from 0 to 6. Okay, integrating this we get theta equal to 2 t cube by 3 limits 0 to 6 minus 1 by 3 t to the power 4 upon 4 limits 0 to 6. Solving this, we can write 6 cube as 6 into 6 square 3. Here we can cancel out the 3 as 2 minus 1 by 12 6 square into 6 square. 6 square is 36, hence this can be written like this. Solving this, we can write 4 into 36 minus 3 into 36, hence 1 into 36 equal to 36 radians. What is asked? The number of rotations is asked. Hence, we need to divide this theta by 2 pi, because in one rotation 2 pi radian is covered. So dividing 36 by 2 pi, we get 18 by pi. On comparing with the given k by pi expression, we get value of k equal to 18. Hence 18 is the answer of this question.